Hey everybody, welcome back. We've got the built Voron V0 now moved for the first time into its final spot where it's going to live here in my studio. It's a small room, right? So it's really only like 2 feet away from the spot that it's been all the way up until this point as we've been building it. But I'm excited that it's finally, kind of in its final place and we can do some final testing and tuning to get it ready to print. And so that's what I have in mind for today. I have 3 things that I want to look at. The first is going to be pressure advance. So we can adjust pressure advance per filament later on, and we'll probably tune a few of the common filaments that we're going to use in this printer specifically to get pressure advance values. But I want to get a kind of a sane default to put in the Klipper config so that when we don't tune pressure advance for a specific filament, we'll have a good default value to fall back on. So we'll do a test print today and figure out what that value should be for our Klipper level kind of global pressure advance setting. Likewise with retraction. So again, we can adjust retraction per filament if we need to, but I want to have a good sensible default in our Klipper config. So we'll set up firmware retraction in Klipper and we'll do a test print to figure out what the value should be that we put in for that. And then the third thing I want to do is I want to test the skew. So I want to make sure that when we built this thing that I got the X and Y axes as perfectly perpendicular to one another as possible. And there's a test print that we can do to measure whether that's off by just a little bit or not. If it turns out that it is off by a little, there is again a Klipper config setting that we can put in place that will adjust for that as well. So that way when we go to print very finely detailed things in the future, the dimensionality will be just as perfect as we can possibly make it. So that is the plan for today. Before we get into those 3 things, I wanted to mention a couple other things because as we've been going along in the series, I've been trying to let you guys know about any additional kind of mods or other things that I print to go along with the printer. These actually really don't probably count as mods, but they were handy little things that I've printed to help with this setup here. So there's 3 of them, and I'll put the links to these down in the description of this video so that you can go and download and print these STLs if you're interested for yourself. The first one's been on the printer for a little while, so you might have already noticed it, but I don't think I've ever mentioned it before. And they're these little white handles here. They go on the sides of the printer. They replace the middle of the clips that holds these acrylic panels on the sides in place. But they're just low-profile handles, and as I've been moving this thing around and getting it set up, they've been super handy to just grab this thing and move it around, and they don't take up a lot of extra space, and they actually, I think, look really nice. I printed them in the white to match kind of the front bumper here on our Kirigami bed, and I think they look really good. So those have been super helpful. And then the other 2 things have to do with this pegboard. This is an IKEA Scatus, I think is what it's called, pegboard that I have mounted here on the wall behind the printer. And so I printed a couple of accessories that mount onto that pegboard to help us out. The first is just storage here for our build plates. So this stores up to 3 of these 120mm square build plates. So I've got my extra build plates in there. I like these Honey Badger ones that I order online. This one actually came with the printer, and it has, I don't know if the camera's picking it up, but it's got this kind of carbon fiber sort of texture on the back side of it. I haven't tried printing anything with this yet, so we'll, at some point in a future episode, we'll have to try this out, see how much of this texture transfers onto the first layer of anything that we print on this particular build plate. Right now I have the Honey Badger one in there with kind of like a satin-ish PEI texture on it. I really, really like these. I've got one for my big Voron as well. They're not quite as textured as a normal textured PEI plate, and they're not perfectly smooth either. They're somewhere in between, and they produce such a nice finish. So I think this is going to be the one I use most of the time, but I've got the other ones up there and easily within reach if I ever need to swap things out. So that's cool. And then the other thing, because I wanted to push this all the way up against the wall, or as close to the wall as possible here on this table. Normally the spool holder is on the back of these little V0 printers, and that's what we've been using up until this point, but it would be in the way. It would be hard to load filament back there, and so I printed out a pegboard mountable spool holder. It's also a roller. You put a couple bearings in it when you build it, when you put it together, and I haven't tried it yet. It's just got this, I've just put a spool on it for the very first time, so we'll try it when we do our test prints today, but it looks really, really promising, and it'll be easy that way to just load a spool of filament over there and still feed it in the printer the same way that we had been doing. And then I've just folded up the spool holder that came with the printer and put it in its like stored configuration where it's folded against the back of the printer so that it's not taking up space back there behind the printer. So that's our setup. That's how it's all going to work. Also, since I mentioned the filament, this is a new roll of this light gray matte PLA. I've ordered a couple of rolls. They just came in yesterday, and this is what we're going to use from now on for most of our test prints as we go through our calibration procedure here. We've been printing mostly with ABS up until this point, and that's just because on my big Voron over here, that's what I print with most of the time, and so that's what I had here, you know, sort of in my stockpile, is a lot of different colors of ABS. And the kind of drawback with that is we have to wait for the chamber to heat up every time I do a test print. I also can't print with this thing open with ABS, but I can with PLA. So we're gonna, from now on, be printing with the top up and probably the door removed as well. So hopefully I can get you guys better camera shots of the inside of this thing as it's printing, because we won't have the enclosure in the way, and the prints will take less time to prepare because they don't have to heat up the chamber and all of that to get to the temps that I like to print the ABS at. And so this is the configuration that we're going to use now going forward. Let's jump over to Orca Slicer, and I'll show you how we prepare these test prints for the 3 things that I mentioned that we're going to test today. And yeah, let's get started. Alright, so here we are in Orca Slicer, and I've got the correct printer loaded up, and we're going to start here with tuning pressure advance. If you're not quite sure what pressure advance is, I will explain that in just a minute when we look at the test print, because I think it's easier to explain there. But before we get there, there's one thing I want to check. I'm going to jump over to the Device tab and look here at our configuration under our extruder section of the config, which for me is in this file right here, because I think we might already have a pressure advance value set. Yes, and we do. So right here, these 2 lines, I'm going to just go ahead and comment these out. These came from, so I didn't put these in here. Well, I did, right, because I copied and pasted them in here. But these came from the suggested default config for our Orbiter 2.0 extruder that we installed on our Dragon burner. So a few episodes ago, when I upgraded from the mini stealth burner to the Dragon burner print head, and I copied the config for that extruder, that's how these values got here into our setup. And so these are the ones that are, this is the value of pressure advance 0.025 that was suggested by, you know, the official config for the Orbiter extruder. And so I'm going to comment them out for now. I'm going to hit save and restart just to restart our printer without those values in there. And when we run our test, we'll go back and we'll compare what we end up deciding that the correct value should be with that suggested value, just because I'm curious to see you know, whether their suggestion was very close to what I decide I want to use. So now back in the main Orca Slicer tab here, we can go ahead and set up our pressure advance test. And so what I'm going to do is just go up to the calibration menu, and under calibration you can choose pressure advance. And we have a direct drive extruder. I'm going to choose the PA pattern style of test because I like it. It prints really fast and it's fairly easy to read. But you can look at the Orca Slicer has good calibration documentation. If you go up here under calibration and you go to the tutorial, it will open a web interface, a web page that shows you all kinds of information. So you can read about these other 2. But for me, I'm going to use PA pattern, and the default settings always work fine for me. They start at a pressure advance value of 0. They go up to 0.08 in 0.005 increments, and we'll see what that looks like here in a second when I hit OK, and then I slice this print, and we can see this is what's going to print, right? And so what we're interested in when we read pressure advance is what this corner looks like, this 90-degree corner here where the extruder has to change directions. And what we're measuring and what pressure advance is adjusting for is, if you imagine the extruder coming down here and then turning this corner, the print head is going to have to physically slow down to turn this corner. And so if the extruder continues extruding plastic at the same rate as we slow down to turn this corner, we're going to have extra plastic right here on the corner. And so you get a little bit of an extra kind of a bulb there, an extra bulge on the right on your corner. And that's what we're trying to eliminate with the higher values of pressure advance. What they do is they cause the extruder to slow down its amount of extrusion as the print head slows down into corners, and then speed back up as the print head speeds up out of corners. And so the higher values will cause the extruder to slow down more as we go around corners. And what should happen, what we should see down here at the very high values, is that we're starting to slow down too much and we're not getting enough plastic. And so we'll start to see some gaps between these 3 extrusions here down at these high values. So somewhere in the middle will be a corner that we can visually look at and see that we don't have extra plastic, we don't have like a bulb on the corner, but we also aren't starting to separate at our 3 extrusions here, and we know that that's the correct value, then we'll go up here and we'll use the number, the nice little handy guide that they put up here to figure out what number that corresponds with, and that's what we'll put into our configuration for our pressure advance. And so I'm gonna go ahead and send this over to the printer, and then we'll take a look at it once it finishes printing, and we'll decide what value is going to work for us. Okay, so that finished nice and quickly. Let's just go ahead and try to take the build plate off here and just take a look at what the results were. See if I can get the camera to focus on this. So, not sure how well this is going to pick up, but you can see, or at least I can see in person, that kind of bulge we're looking for on the corners down, you know, up here on the lower values of pressure advance. And then down here on the highest values, there are definite gaps starting to appear between the extrusions. You know, I can see it starting to separate down there. And so just looking at this, the best value that I see, like kind of where we start to have a good middle ground between the very obvious bulge down here and the starting to separate, is actually probably right around here, this point right here. So if I follow this line back up, that is 0.04. And I might go down a half step kind of in between these two to maybe 0.35 just to be safe. I'd rather have my pressure advance value be just a little bit high and still have a little bit of a bulge on those corners, as opposed to, you know, running the risk of having our lines separate and, you know, affect the toughness of our prints around corners. And so 0.035, I think, for me, just looking at this test print, is the value that we want to go with. So let's jump back over to Orca Slicer and change the config in our machine, in our Klipper config, to 0.035. So back in Orca Slicer on the device tab, looking at our web UI for our printer, and over here in the machine tab, we can just go back to that same spot where we've already looked to see the pressure advance, and the value I liked was 0.035. So their default value that they wanted me to use when we configured this extruder was 0.025. We'll go up to 0.035 here, because I liked that, the look of that a little bit better. And then this pressure advance smooth time just impacts how quickly or slowly it gets, you know, it changes values as it gets around those corners. The 0.03 default I've always used, and it's always been fine in all of my different Klipper printers, so we'll just stick with that. So 0.035 for our kind of global pressure advance value, and again, we can override this per filament if we need to in the future, but this way, if we ever print with a filament that we haven't specifically tuned and set a pressure advance value for, it will just fall back to using this 0.035, which seems to be a very good value for this particular printer. So I'll go ahead and save and restart that, and then we will jump over to back to the Orca Slicer Prepare tab, and what we want to do here is just create a new project and don't save any of our settings. So you'll notice as you run these calibration prints within Orca Slicer, it overrides some of your default settings, you know, for layer heights and flow rates and things like that. So each time that you go to finish this and go to do a new one, you want to create a new project and discard all of the settings that it might have changed so that you're starting from a clean slate. And so now we will move on to the next thing that I wanted to test, which is retraction. So now let's figure out what value we want to put into our Klipper config for our firmware retraction. And just like we did with pressure advance, I'm going to go over and look at my settings right now. For me, firmware retraction will be in here, and just see if I have anything in place. And I do. I have retraction length of 0.5 millimeters, which I'm pretty sure that this just came from, I copied and pasted in some settings from one of my other printers, but also I've seen some tuning guides just say put 0.5 in there and you're probably fine, and then you don't need to worry about it. So this is a pretty standard default that you might see. Again, we're going to comment this out and save and restart Klipper just to be sure that we don't have any settings already in place. And so then we can jump back over here to our setup tab. And again, we're just going to use that same generic PLA that we had used before. And we're going to go up to the calibration menu and choose retraction test. Now, in this little dialog that pops up, we want to definitely start at 0. I don't think that we're going to need a firmware retraction value of anything bigger than 1. The 0.5 was probably actually, the max of what we might need anyway. So I'm going to change this down to 1 instead of 2 just to save time on the print, because I don't think the values greater than 1 are going to matter at all anyway. And we're going to go by 0.1 millimeter increments, and that seems okay. So now we can see here that we have these two little towers, right? And so what we're going to be measuring on this test is the print head's going to print one of these circles and then jump over here and print a circle and then jump back and print a circle and jump back and print a circle and so on as it goes up the print. And what we're looking for is to see if there's any stringing in between. So when it hops back and forth between the two little circular towers that it's printing, do we see stringing? And it's going to start with a 0 value for the firmware retraction at the bottom here. It prints these nice kind of little ridges so that in the final print we'll be able to count up. So this is 0, 0.1, 0.2, 0.3, 0.4, and so on all the way up to 1. And that way we'll be able to see which value corresponds with whatever stringing that we're seeing between the prints. We expect to see a little bit of stringing down here at the very low values and for it to disappear as it goes higher up. And when we see, whatever level we see the stringing disappear to the extent that we're happy with, that's the value that we will use. And so we'll go ahead and send this, again, we'll slice it and send it over to the printer. Again, this one doesn't take very long, which is another nice thing I like about this type of print, and limiting the height of it, to limit the upper range of the value to something that you think is probably within what you're going to be looking for is beneficial, because it just cuts the print time in about half in our case, compared to if we had gone all the way up to a value of 2. So I'm going to send this over to the printer, get it printed, and we'll look at the results. All right, once again, we've finished printing. And I'm going to pull this off and try to get a good view for the camera. Try, especially with this print, right, not to disturb it at all when you're moving it around, because it's real easy to, mess with any amounts of stringing that you might see. I'm going to remove the purge line here. Just pull that off. Being careful not to touch the rest of the print, just to get it out of the way so that we can see this a little bit better. Alright, so what I'm seeing is some definite stringing down here low like I expected to see. Weirdly, I'm seeing a few random strings up high and then a gap in the middle where there was no stringing. That's not something that I've seen too much before, so that's interesting to me. But as I was expecting, this extruder, what I was expecting from this extruder was not very much stringing at all and not very much need for any amount of retraction. Any very large amount of retraction at least. And so, I'm seeing down here at the 0.1, maybe 0.2 level, some amount of stringing. And then above that, I'm not seeing anything except, like I said, this little bit of extra stringing way up high here. And I'm thinking that maybe is just, I don't know that I trust this particular filament yet. I mentioned earlier it's a brand new roll of PLA. I've never used this brand or, this type of PLA before. So it might be that. I didn't mention earlier, but you should probably use a filament that you trust, in the sense that you're sure that it's not too wet, that it hasn't absorbed a lot of moisture, because again, that can cause stringing, and what you're trying to measure here is what your extruder can do and not necessarily what's being impacted by your filament. So for me, looking at this, I'm happy with setting my retraction value to somewhere around 0.2 or 0.3, and everything above that isn't really making any sort of appreciable difference. So we'll jump back over to Orca Slicer. We'll probably use 0.3 for our value, just erring again on the side of being more conservative, putting a higher value in there, just to be sure that we're not introducing any unnecessary stringing based on how our extruder's working. So 0.3 is the value I've decided to go with. Let's go ahead and put that into the system. So once again, back here in our device tab in Orca Slicer, we can just jump over to my settings config file is where I put my firmware retraction settings. And so we'll put those in here, and we'll go ahead and set that to 0.3. And the speed we can leave at the default of 35. That seems fine to me. So again, save and restart, and then that value is now in place, and will take effect anytime we don't override it for a specific type of filament or for a specific print. All right, so once again, we go with a brand new file here and discard all of the changes to settings that Orca Slicer may have created for us there for that test print. And now I want to test Skew. And so what that's going to require is loading a special print file, not a built-in one to Orca Slicer. Let me jump over and find that file, and I'll explain to you a bit about what it is, where I got it, and how you can use it. All right, so I've got the test print loaded in here that we're going to use to test the skew of our printer. And this is actually also really, really good print for testing just the dimensional accuracy of both your printer and a specific filament. So we'll use this again when we go to calibrate specific filaments as well. I should mention this is not a free STL to download, so you have to purchase this one. I will show you here on the screen the vector3d.com website where you can buy this, and I'll put a link to it down in the description below. This is, of course, not sponsored by them or anything like that. This is just a tool that I've found to be really, really useful, so I use it a lot when calibrating filaments, and also for this specific purpose of printer skew as well. So what this does is it allows you to use calipers, as they show here, for measuring different points on this test print, and then they give you a downloadable spreadsheet file as well that is pictured here in this little screenshot that lets you enter all the values that you get from your readings from your calipers for measuring all these different points, and it helps to calculate any shrinkage that you have or any dimensional problems that you might have with the precise dimensions of what your printer is outputting, and then it also can calculate skew. And so what we're going to use it for here today is just the skew calculation. We'll come back to it again, like I said, probably when we calibrate specific filaments later on as well. So with this print, you want to load it in to your slicer, and you want to center it on the bed. You want to make sure that the arrows are pointing up in the y-axis and to the right on the x-axis as well. So these little arrows in the top of the print will help us to keep it oriented correctly later on when we take our measurements as well. And so you want to make sure it's oriented this way, which is the default orientation that just happens when you load it into the slicer. You want to, again, we're just going to use the generic PLA setting, but you want to pull up whatever setting you have for the type of filament that you're going to use, and you want to use whatever standard print settings that you're going to use most of the time on your printer as well. So this one I think is going to take a little bit longer to print than I'm used to, so I'll go ahead and slice this and we'll see how long it thinks it's going to take. Yeah, so more than 2 hours for me here, and I'm not used to it taking this long, but again, we're printing with a 0.25 millimeter nozzle and a 0.1 millimeter layer height. And so it does take quite a few extra layers to print this, quite large object. So normally for me on, a larger printer with a 0.4 millimeter nozzle, I think it takes about an hour to print this thing, but it's going to take about twice that long here. So I'm going to go ahead and send this over to the printer, and then we'll actually take it off of the build plate when it finishes. The other test prints, we've looked at right on the build plate, which I think is good. This one comes out nice and sturdy, so you can go ahead and just remove that from the build plate. I'll bring it back over here to the build desk and pull out my calipers, and we'll go through the process of doing the measurements and punching those into the spreadsheet and seeing some results once it's completed printing. Okay, so our cauliflower finally finished printing. This actually took longer than was even estimated by my slicer. I think it took over 3 hours to print. I went away for a while and came back, and it was finally done. And so, but it does look good, and actually, let me get you a closer look here. The top surface of this print is so amazingly smooth. I am, especially since we haven't fully calibrated this filament yet, I'm really, really impressed with how this filament is printing. So that's a good sign for future prints that we do that are more interesting than just calibration objects. But what we do with this thing is there's a spreadsheet that came along with the download of the file, And so I'll pop that up on the screen here so you can see it. And what it does is it has all of these numbered measurements of different sections that we're supposed to take measurements of. And the instructions on the tool there are pretty well defined, so it's fairly easy to do. The only trick is to make sure you've got it oriented correctly with these little etched arrows on the top here pointing up and to the right. To figure out how to align this thing. And so all we're going to do is we're going to take our calipers here and go ahead and make these measurements. And so there are some outer measurements. So like from here to here is the number 1 measurement there on the tool. And all of these larger measurements should be about 100 millimeters. So the nice thing is they give you these little sort of nubs here to back the clippers up against so that you're sure you're getting a nice perpendicular measurement, right? So you take that measurement and they want you to take it, I'm getting about 99.63 or so right at the moment. And my calipers, the battery's dying, so that's why they're blinking like this. So hopefully they'll last through this exercise. But they want you to take 3 different measurements, kind of loosen it and put it back a couple of times. And then on the spreadsheet for reading 1, there are 3 spots to put those measurements. And so you put that in there. There are some smaller measurements as well, so like between here and here. And these smaller ones are all meant to be about 50 millimeters. There are a couple of inside measurements as well you take, like so here to here. And the nice thing about those is, again, these little end stops are made so that the calipers, the flats of the calipers back up right against there, right? So this one's hitting down here, this one's hitting up here, and you can get a nice perpendicular measurement to measure this. And so what I'm going to do now is just go through and take all of the measurements that are necessary and plug them into this spreadsheet. Actually, for testing skew, which is what we care about right at the moment today, really the only 2 measurements that matter are these 2 diagonal ones. So this one right here, and then the corresponding one on the opposite diagonal here. And those, I believe, are measurements 9 and 10 here on the spreadsheet. So I could just do those 2 and we would get our skew calculation. But since I haven't calibrated this filament before for shrinkage, and we'll do that in a future video, I'll talk about calibrating filament and we'll go back and use this test again. But I'll go ahead and grab those numbers too while I'm here. So I'm just going to grab all of these real quick, and then we'll come back and we'll take a look at the results. So with all of those measurements entered in place here in the top of our spreadsheet, we can look down here and we can see a couple of things. First of all, we've got some shrinkage in X and Y that we can correct for, and we'll do that later on. It's interesting that the X and Y shrinkage is different, but that's probably related to the fact that there is some skew here. So we've got 0.19 degrees of skew. So we're 0.19 degrees off of our straight 90-degree angle between the X and Y axes. And that seemed a little high. I was a little surprised about that. I double-checked those measurements, so I'm fairly confident that that is the case. And so the nice thing about this tool is down here, if you've got Klipper firmware like we do, and also they have some settings for Marlin as well, but we use Klipper, so we can do this. And it shows you the things you need to add. So we have to add skew correction to our printer config to get that loaded, and then we can send these commands via the console, and then we can add this little, that sets up our skew profile, and then we can add this G-code here to our start print that will load that calibration profile for our skew. So I'm going to put these values now in the right spots in my printer config files, and then I'll restart Klipper. And then at that point you could print another one of these, you know, objects, one of these calibration flower objects again, and you could double check the skew and be sure that it's correct. I've done that on other printers. I'm not going to do it on this one, at least not right now, because I know we're going to be printing more of these to calibrate some filaments later on, and so I can always just use those as a way to check that I've fixed the skew, because I don't want to spend another 3 hours printing another one of these just to double check the skew correction. But we'll go ahead and get that put into the printer config, and then I'll come back and we'll kind of wrap up the episode with a few final thoughts. So I've made those changes to our config just to show you what that ends up looking like so in my settings config file, which is kind of my global settings for the printer, I added that skew correction line just to load Klipper's skew correction module. And then we entered those 3 commands in the console, just like over here in the dashboard. I put those, there you can see them here. the set skew and then saving it as a skew profile and then saving the config. And when you do those three things, what ends up happening is over here in your main printer config file, there's in this little commented out section that Klipper creates automatically at the bottom here to save some settings. It adds this skew correction, so you can see that it's got it's named cauliflower, and it only is correcting in the XY axes, axis combination. The XZ and the YZ are 0 here. So, and it's a very small number. So I think that is all correct, and so that gets loaded automatically as with a named skew correction profile when Klipper starts. And then over here in my macros config, in my print start macro, right before we start printing, I added this line to load that cauliflower skew profile. And then when we ended printing, before we do much else, I clear that profile back out. And so those were the instructions that came with the cauliflower spreadsheet file that we filled out. So that all looks good. We won't test these today. We'll do that the next time when we do some test prints. But everything is looking good now for kind of our global printer configuration settings, and the quality that we're getting out of this particular filament looks really good already. But what we'll do is we'll go ahead in the next episode and come back and fine tune this filament. So we'll tune its flow rate. We'll probably check pressure advance on it again just to be sure. We'll dial in the exact temperature that we want it to print at. Although the default the temp that it's been printing at so far in this generic profile seems like it's really good. But we'll do all of those things just to be sure that I don't want to change any of those kinds of things in the next episode. And that will show you guys as well how I like to calibrate a new filament when I get one into my collection here and I've not printed with it before. Those will be the tests that we run through next time. So I know a few of you have been asking about that from previous episodes. So that'll be coming up in the next one, probably in a couple of days. And until then, if you want to stay tuned with everything that's going on, make sure you get subscribed and watch this playlist. This is where new episodes will appear. And again, thanks for watching. If you've been with me ever since the beginning when we started building this printer, what's it been, like 3 weeks ago, and almost everyday episodes for a while now. It's been a lot of fun, and we're getting to the point where we're almost ready to start printing some cool stuff. And so I'm looking forward to that, but we've got a couple more fine-tuning episodes yet to go. So I hope you are looking forward to those. I am. And until then, I will see you next time, and I hope you have a great day.